this square plus this square plus this square plus this rest is greater than or equal to 4ab plus 4bc plus 4ac minus 2a squared minus 2b squared and then minus 2c squared. Here I have a suggestion. Now let's add 2a squared plus 2b squared plus 2c squared and minus 4ab minus 4bc minus 4ac. Let's see what we have. By the way, I have noted this sum of squares with s because this is positive. So we will get this relation. S plus this rest minus this is greater than or equal to 0. Now here I see something special. Look at this sum. We have here 2a squared plus 2b squared plus 2c squared minus 4ab minus 4bc and then minus 4ac. I have a question. Can we write this sum like 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ac and then once again minus 2ab minus 2bc and then minus 2ac, which is greater than or equal to 0? Yes, we can. But what do we have to do with this part? You will see. But first of all, let's calculate this square, a minus b all squared. This is equal next to it. A squared minus 2ab plus b squared. But b minus c squared is b squared minus 2bc plus c squared. And then c minus a squared is equal to c squared minus 2ac plus a squared. What happens if we add them? It follows that a with a we have 2a squared and then plus 2b squared plus 2c squared, and now with minus 2ab minus 2bc minus 2ac. So this sum of three squares is equal with this, which is even this. So this expression can be written like a minus b squared plus b minus c squared plus c minus a all squared. So this expression can be written like this. Okay, here I have some observations. Because the sum that we noted is greater than or equal to 0, and this sum of three squares is also greater than or equal to 0, we have to show that also this sum 2ab squared over c plus 2bc squared over a plus 2ca squared all over b and then minus 2ab minus 2bc minus 2ac will be greater than or equal to 0. We have to prove this one because these two terms are already greater than 0. Because we want to have the same denominator, we will amplify here with c, a, and here with b. And we have that 2ab squared minus 2abc over c plus 2bc squared minus 2abc over a plus 2ca squared minus 2abc over b is greater than or equal to 0. Here we will amplify with ab, here with cb, and here with ac. So we have that 2a squared b cubed minus 2a squared b squared c plus 2b squared c cubed minus 2ab squared c squared plus 2c squared a cubed minus 2a squared bc squared all over a times b times c is greater than or equal to 0. Because this product a times b times c is positive, we can't divide by him because we don't need it. Now another thing that we observe is this coefficient 2. We don't need it, so we can divide by 2. So we are remaining with the coefficient 1. The next thing that I see is that we can factor this sum like this. From here we have a squared b squared times b minus c plus now b squared c squared times c minus a, and then c squared a squared times a minus b, which is greater than or equal to 0. Now I know that we have to show this. This is not already true. We have to prove that this is true until now. But so far so good. I have an idea. Let's divide this by ABC all squared. So we have, now we can simplify this with this one with this one, and finally here. So we have, now we can decompose these fractions. So we have this fraction equal with this, and then plus c over a squared minus a over a squared, and then plus a over b squared minus b over b squared, which is greater than or equal to 0. I know we have to prove this. We can make some simplifications here. So we have b over c squared minus 1 over c plus c over a squared minus 1 over a, and then plus a over b squared minus 1 over b, which is greater than or equal to 0. Now here we can add plus 1 over a plus 1 over b and then plus 1 over c, because we will have to prove that b over c squared plus c over a squared plus a over b squared is greater than or equal to 1 over a plus 1 over b plus 1 over c. Here I have a nice observation. 1 over a plus 1 over b plus 1 over c, but all squared, is equal next with 1 over a squared plus 1 over b squared plus 1 over c squared, and then plus 2 times the quantities 1 over a times 1 over b plus 1 over b times 1 over c, and then plus 1 over c times 1 over a. So 1 over a plus 1 over b plus 1 over c all squared is equal next with these sums, and then plus 2 over ab plus 2 over ac plus 2 over bc. Because we are interested about just 1 over a plus 1 over b plus 1 over c, we will take the square roots.